Dear learner, I welcome you all to the massive open online course on power generation technologies. I am Sanjay Agarwal, Professor and Pro Vice Chancellor of Chhattisgarh Swami Vivekanand Technical University, Bhilai. So before the start of this lecture, let us recall about the last lecture. So dear learner, in the last lecture we have already discussed introduction about the integrated gasifier based combined cycle system, and after that we have already discussed working and construction details of integrated gasifier based combined cycle system. At the same time we were focused on what are the different benefits and drawback of this integrated gasifier based combined cycle system. Dear learner, in this particular section we are going to discuss on particular topic, that is solar power plant, and under this particular topic we will cover about what is a solar energy, then we will discuss what is a solar thermal power generation, and after that we will discuss different type of solar thermal power plant and what are the benefit and drawback of solar thermal power plant. And after that we will discuss what is a solar cell and how does this solar cell work, and lastly we will also discuss what is solar PV power plant. So before the beginning of this lecture, let us discuss about solar energy basics. The sun is one of the major renewable energy sources. The radiating light and heat from the sun are harnessed and converted into other form of energy. Let us learn about solar energy in detail. Solar energy is a form of renewable energy derived from the sun radiation. It is the process of capturing and harnessing the energy produced by the sun and converting it into usable form of power, that is electricity and heat. Solar energy is considered a clean and sustainable source of energy because it produces no greenhouse emission, or you can say air pollutants, during this particular operation. Solar energy uses the sunlight and heat to generate renewable, or you can say green power. The most common form of solar energy is harnessed by the solar panel, or you can say photovoltaic solar cell. In photovoltaic power station, they are arranged almost as to as capture sunlight in large field. You will also see them on top of the houses and the other building at times as well. The cells are created from the semiconductor material. When the sun ray hit the solar cell, it loses the electron from their atoms, and this allows the electron to flow through the cell and generate electricity. On a much larger scale, solar collector can generate power from thousands of the people at once. Solar thermal power plant use a variety of technique to produce power using the sun. The sun energy is used to boil water, which in turn operate a steam turbine to generate in a similar fashion to that of coal or nuclear power plant. Now let us discuss about some of the major application of the solar energy. So there are different applications, like it can be used for the solar water heating, it can be used for solar heating of the building, it can also be used for the solar distillation system. Solar pumping is also one application of this one, and solar energy can also be used for solar drying of agricultural and the animal products. Solar energy can also be used for the solar furnace, solar cooking, solar electric power generation, and this can also be used for solar thermal power production and in solar greenhouses. Now we will discuss what are the advantages and disadvantages of the solar energy. So first of all we will discuss what are the different advantages of the solar energy. So first advantage is solar energy is clean, means it is considered to be the cleanest form of energy, as there is no carbon dioxide emission like in case of fossil fuel, which is in one of the causes of the global warming. Second advantage of solar energy is it is a renewable, means there is a ample energy available on earth as long as sun exists. Third advantage is it is reliable. The energy can be stored in the batteries, so there is no unreliability. Another advantage is reduction in the utility cost, and solar energy is also free energy because it can be trapped very easily. Now we will discuss what are the disadvantages of the solar energy. First disadvantage of solar energy is the production is low during the winter and on cloudy days. Second disadvantage is installation and the initial cost of the material are very expensive. Third disadvantage of solar energy is space consumption required is more because you are going to install the solar photovoltaic module, so for production of electrical energy more space is required. In summary, we can say solar energy offers numerous benefits including sustainability, reduced energy cost and environmental benefits. However, it also has limitations such as intermittency and high initial cost, which may need to be addressed through technological advancement and improve energy storage solution to fully realize its potential as primary source of electricity. Now let us discuss in detail of the solar power generation technique. So there are two main type of solar energy technologies. One is concentrated solar thermal power and second one is solar photovoltaic. Now we will discuss process of solar thermal electricity generation. Solar thermal power plant are electricity generation plant that utilize energy from the sun to heat a fluid to a high temperature. This fluid then transfer its heat to water, which then becomes superheated steam. Then this steam is then used to turn turbines in a power plant, and a generator converts this mechanical energy into electricity. This type of generation is essentially the same as electricity generation but use fossil fuels, but instead heats steam using sunlight instead of combustion of fossil fuels. This system uses solar collector to concentrate the sun ray on one point to achieve appropriately high temperatures. There are two types of system to collect solar radiation and store it. First one is passive system. So what is a passive system? It requires no equipment, like when heat builds up inside your car when it is left parked in the sunlight. The example of this passive system is thermal chimney. Another system is called active system. Active system requires some way to absorb and collect radiation and then store it. For example, solar thermal power plant are considered active system. These plants are designed to operate using only solar energy, but most plants can use fossil fuel combustion to supplement output when needed. Now we will discuss different type of solar thermal plants. In an effort to utilize solar energy for power generation, various systems are classified. First one is low temperature solar power plant using flat plate collector. Second is medium temperature solar power plant using concentrated solar collector, and third one is high temperature solar power plant using tower system. So first we will discuss low temperature solar power plant using array or flat plate collector. The low temperature solar power plant use the working fluid temperature in the range of 60 degrees centigrade to 100 degrees centigrade, which can be obtained using flat plate type collector or by the solar pond. The efficiency of such plant is only in the range of 2 to 3%. The working fluid used in such plant are fluid having low boiling temperature at atmospheric pressure. The fluids are refrigerant R11, butane gas, etc. The system requires storage system. Now we will discuss low temperature flat plate collector solar power system. Since the water can be only heated 80 degrees centigrade in flat collector, the system needs to use working fluid having low boiling temperature like a butane gas. The system consists of an array of the flat plate collector. The cold water is circulated into the collector with help of circulating pump. The water gets heated in the solar collector due to the solar radiation up to temperature of about 80 degrees centigrade. The heated water is circulated in a heat exchanger called butane boiler, where it generates the butane gas at high pressure. The butane gas is supplied to a butane turbine to produce mechanical power due to expansion of the butane gas. The vapor coming out of turbine is condensed in a condenser and sent back for recirculation with help of butane feed pump. Then the mechanical power output of turbine is converted into electrical power by generator. Now we will discuss solar pond electric power plant. The system work on the Rankine cycle using R11 as a refrigerant. The system use a solar pond for collection and storage of solar energy. The heat of hot brine solution from solar pond is used to evaporate the working substance R11 at constant pressure in the boiler. The vapor is used to run the vapor turbine to produce mechanical power, which is utilized to run generator to produce the electrical power. The exhaust of turbine is condensed in the condenser at constant pressure with help of cooling water. The condensate is returned to the boiler by a pump. Thus, cycle is repeated. Low temperature thermal power plant are only suitable for very low power generation, having very low efficiency. Hence, these are not used in practice. Now we will discuss medium temperature solar power plant. This system employ an array of parabolic through concentrating collector spread over a large area. The general range of working temperature are between 250 degrees centigrade to 400 degrees centigrade. The parabolic inline focusing type collector are used and generally preferred because of low cost and require sun tracking in one plane only as compared to paraboloid concentrating collector having high cost and require sun tracking in two plane. The system work on Rankine cycle. The schematic diagram of medium temperature solar power plant using in parabolic through concentrator is shown in this figure. The system consists of an array of large parabolic through collector duly installed with sun tracking device to collect the solar radiation, which is used to heat a fluid, that is a water, and this heat is transferred to storage tank and finally to fed water, where the steam is generated in the steam generator. This steam is utilized to run a turbine coupled to electric generator. The mechanical energy developed by turbine is converted into electric power by the generator, and the exhaust of steam turbine is condensed in the condenser with the help of cold water circulated in the condenser. The condensate is returned to the boiler with the help of feed pump. The hot water leaving the condenser is either sent to the cooling tower or its heat energy can be used as process heat if plant is used in an industry. A plant can be developed using air as a working fluid instead of steam based on Brayton cycle as discussed earlier. Now we will discuss high temperature solar thermal power plant. For efficient utilization of solar heat energy into electrical energy, the working fluid has to be supplied at high temperature. Large solar thermal power plant can be built in the capacity of 50 megawatt to 200 megawatt, and such plant are paraboloidal disc collector or heliostat. This system have high thermal efficiency. Now we will know what is a solar thermal power plant using disc collector. The solar disc collector receives solar radiation which are collected at a common focusing point. A small volume of the fluid are heating at this point to high temperature. The heat is utilized to run a prime mover based on the Stirling cycle. A similar system has been built in Hyderabad which generate 30 kilowatt power at about 30% efficiency. It uses 4 disc collector in series to generate high pressure and temperature and utilize the steam for generation of electrical power in conventional system working on Rankine cycle. And due to limitation of the size and the small quantity of load, this type solar power plant are not suitable for generation of power beyond the few kilowatt. For this reason, such plants are not built for the large power generation. Now we will discuss central tower receiver power plant using heliostat. Such plant use central tower receiver. It uses an array of plane mirror called the heliostat, which are individually controlled and tracked to reflect the solar radiation on receiver kept on a tower of about 500 meter height. The fed water in the observer receiver called the boiler is converted into high temperature steam of about 600 degrees centigrade to 700 degrees centigrade. This steam is supplied in a conventional steam power plant coupled to electric generator to generate electrical power as shown. A thermal storage system can be provided for use on cloudy days. A pilot plant of 50 kilowatt was built in Italy. However, the plant based on the system have been commissioned in various countries in a capacity of 1 megawatt to 10 megawatt. The present cost of power generation is very high. It is approximately to rupees 4.6 crore per megawatt. Now let us discuss about the benefit and drawback of solar thermal power generation. So what are the different benefits? First is it saves costly and depleting fossil fuel. Second advantage is it is pollution free. Third is it do not require fuel transportation. Third is it can be installed far away from fuel sources and in remote areas. What are the different drawbacks? First is the cost of power generation is very high. Second, it needs standby power. Third, it needs very large collector area for the installation. Third, it cannot supply continuous electrical power. Another drawback is it is only suitable where favorable sunshine conditions are available. Next drawback of such system is it has low thermal efficiency and it also needs thermal storage system. So before the start of the topic of solar photovoltaic power generation, let us first discuss what is a solar cell. Solar cell is defined as electrical device that converts light energy into electrical energy through the photovoltaic effect. A solar cell is basically PN junction diode. Solar cell are form of the photovoltaic cell defined as a device which electrical characteristics such as current, voltage or resistance vary when exposed to the sunlight. Individual solar cell can be combined to form modules commonly known as solar panel or photovoltaic module. The common single junction silicon solar cell can produce a maximum open circuit voltage of approximately 0.5 to 0.6 volt. By itself, this is not much, but remember these solar cells are tiny. When combined into large solar panel, considerable amount of renewable energy can be generated. Now we will see what is a photovoltaic effect. The photovoltaic module, commonly called solar modules, are the key component used to convert sunlight into electricity. Solar modules are made of semiconductors that are very similar to those used to create integrated circuit for the electronic component. The most common type of semiconductor currently in use is made of silicon crystal. Silicon crystal are laminated into N layer and P-type layer stacked on top of each other. Light striking the crystal includes the photovoltaic effect which generates electricity. The electricity produced is called direct current and can be used immediately or stored in a battery. For system installed on homes served by utility grid, a device called an inverter changes the electricity into alternating current, the standard power used in residential homes. A p-n junction is formed by placing p-type and n-type semiconductor next to one another. The p-type with one less electron attracts the surplus electron from the n-type to stabilize itself. Thus, the electricity is displaced and generate a flow of electron, otherwise known as electricity. When sunlight hits the semiconductor, an electron springs up and is attracted toward the n-type semiconductor. This causes more negative in the n-type semiconductor and more positive in p-type, thus generating higher flow of electricity. This is the photovoltaic effect. Now we will understand the construction of the solar cell. So basically solar cell is a junction block. Although it's a construction, it is little bit different from conventional p-n junction diode. A very thin layer of p-type semiconductor is grown on a relatively thicker n-type semiconductor. When then apply a few finer electron on the top of the p-type semiconductor layer, these electrons do not obstruct light to reach the thin p-type layer. Just below the p-type layer there is a p-n junction. We also provide current collecting electrode at the bottom of n-type layer. We encapsulate the entire assembly by thin glass to protect the solar cell from any mechanical shock. Now we will see what is an encapsulant. An encapsulant is used to provide adhesion between the solar cell, the top surface and the rear surface of the PV module. The encapsulant should be stable at elevated temperature and high ultraviolet exposure. It should also be optically transparent and should have low thermal resistance. Now we will discuss working principle of the solar cell. So when light reaches the p-n junction, our light photons can easily enter in the junction through the very thin p-type layer. The light energy in the form of photons supplies sufficient energy to the junction to create number of electron-hole pairs. The incident light breaks the thermal equilibrium condition of the junction. The free electron in the depletion region can quickly come to the n-type side of the junction. Similarly, the holes of the depletion can quickly come to the p-type side of the junction. Once the newly created free electron come to the n-type side, cannot further crosses the junction because of the barrier potential of the junction. So now we will discuss the BI characteristic of the photovoltaic cell. So here you can see on the horizontal axis the voltage has been shown and on the vertical axis current has been shown. So here you can see the point of the short circuit current and the open circuit voltage. So here in this particular characteristic, the 20 voltage is the open circuit voltage and approximately 5 ampere current is the short circuit current. And here 2 points you can also see the maximum voltage and the maximum current. So area between this I max and V max, this area is called the maximum power which will be generated under this particular area. Now we will discuss criteria for the material to be used in the solar cell. It must have band gap from 1 electron volt to 1.8 electron volt. It must have high optical absorption. It must have high electrical conductivity. The raw material must be available in the abundance and the cost of the material must be low. Now we will discuss what are the advantages of the solar cell. So as we have already discussed the advantages of the solar energy. So it is just similar to the advantage of the solar energy. So first advantage of solar cell is no pollution associated with it, and second advantage is it must last for a long time and no maintenance cost is involved in case of the solar cell. The disadvantage of the solar cell is it has high cost of the installation, it has low efficiency. During the cloudy day the energy cannot be produced, and also at night we will not get solar energy. Now we will see uses of the solar generation system. First, it may be used for charge battery. It can be used in the light meters. It is also used in power calculator and wristwatches. It can be used in the spacecraft to provide electrical energy. So dear learner, in this particular lecture we have discussed basics of the solar energy. Then we have discussed solar power generation technologies. And after that we have also discussed solar thermal power plant and solar photovoltaic power plant. Dear learner, in the next lecture we will discuss on the following topics, like we will discuss wind energy basics, and after that we will discuss the working principle of the wind turbine, and after that we will also discuss the different type of wind turbine and wind turbine power generation and its component, and in the lastly we will discuss the advantages and limitations of the wind energy in the next lecture. Thank you very much.